The question says the number of solutions of the equation sin to the power 4x plus cos to the power 4x is equal to sin x cos x in the interval 0 to 2 pi is equal to. So let us solve the equation. Sin to the power 4x plus cos to the power 4x is equal to sin x into cos x. This can be written as sin square x plus cos square x the whole square minus 2 sin square x cos square x equal to sin x into cos x. We know that sin square theta plus cos square theta is equal to 1. So this will be 1 square, which is 1 minus 2 sin square x into cos square x can be written as sin square 2x by 2 is equal to sin 2x sin x cos x can be written as sin 2x by 2. So here we are using the formula 2 sin theta into cos theta is equal to sin 2 theta. Alright. So let us take this 2 in the denominator to the numerator here. So let us multiply by 2 on the LHS and RHS. So this will become 2 minus sin square 2x is equal to sin 2x. So this is forming a quadratic equation. So let us solve it. Sin square 2x minus sin square 2x minus sin 2x plus 2 is equal to 0. So multiply by minus sign in order to get the square term in positive. So sin square 2x plus sin 2x minus 2 is equal to 0. So we can find the roots of this equation, which will be sin square 2x sin 2x minus 1 into sin 2x plus 2. So the two roots are sin 2x is equal to 1 comma minus 2 is equal to 1 and sin 2x is equal to minus 2. We know that the range of sin 2x is from minus 1 to plus 1. So minus 2 is out of the range. So this is not a correct solution. Sin 2x equal to 1 is the correct solution. So 2x is equal to 1, which is sin is equal to 1 at pi by 2, which is 90 degrees, and 5 pi by 2. So we want to find the value of x. So that will be pi by 2 by 2, which is pi by 4, comma 5 pi by 4. So if you see, both of these angles are within the range that is given to us 0 to 2 pi, which is this is pi by 4 is 45 degrees and 5 pi by 4 is 225 degrees, and it fits between our range 0 to 360 degree. Hence there are two solutions of this equation, which is pi by 4 and 5 pi by 4. So the answer is two solutions.